So we are talking about using statistical softwares and summarizing data, and this specific section, which is the last section of this lecture, is going to be about diagrams and graphs in medical statistics and research, in which we're going to talk about types of figures and graphs and shapes of distribution and positive and negatively skewed data. So a very common one is a histogram. So let's start off with a histogram. So a histogram is actually a diagram that shows distribution of the data by plotting the data in rectangles, these rectangles here, which are known as bins. And they correspond to the categories along the x-axis or the horizontal axis. Now, this is the horizontal axis. And here we can see that we have categories of height. So this category means 150, 140. So this means 140 to 145 and 145 to 150. So this bin is actually representing 145 to 150 centimeter in height. Now these rectangles have heights or areas which are proportional to the frequency in these categories. Higher the frequency, higher would be the height or the area. Here you can see this is the vertical scale or the y-axis, and here we have the frequency per interval. And sometimes the width of these bins or rectangles may differ, and sometimes they may be the same. If they have the same width throughout, then it is all dependent on the height, and the greater the height, greater the frequency. So which means height of the rectangle will be proportional to the frequency. But if the width of these rectangles or bins is not equal, then the area actually indicates the frequency. So the greater the area, the greater the frequency, or you can say it is there is a direct proportionality between area and frequency. In my opinion, it is best where possible to keep the width same for all the bins because it makes it clutter-free and easier to understand. Now the second one we have is stem and leaf plot. Most of you may not be aware of this type of diagrammatic representation, but it is also a graph, but it shows the main features of set of data. And in this graph, the numbers themselves are used to demonstrate the shape of the distribution, where the leaf is the final digit of each height and stem is all other numbers. So this is the leaf and this is the stem. So it may be used instead of histogram for small data sets or alongside to show patterns of occurrence of certain numbers. Now let's take an example of this stem and leaf plot, for example. So here we have, this is 140, this is 142, this is then there are two means, so I have written 2 only once here. So it means the frequency distribution for 142 is 1. So this is 147 because 147. So 147 also has frequency of 1, 148 has 1, 149 is 1, this is 150. Now 151 has 1, 152 has 1, 153 has 1. But if we look at 154, there are 4 and 4, which means it has occurred twice. So the frequency of the height of 154 centimeter is 2. Similarly, if we take a look at this and we count, there are 10, 7. So it means the frequency of 167 is 10. So this small plot is actually giving us a lot of information, and it makes it very interesting for studies which have small data sets. Now, box and whisker plot. I personally love this plot because it gives us a lot of information, and especially when we are comparing two groups and when we want to give a lot of information in just one figure. So a box and whisker plot contains 5 pieces of summary information about the data, not just 1, 5 pieces. So it is giving us the value of the median. It is also giving us the upper quartile. So this is the upper quartile, this is the lower quartile, and this line is the median. This here, which is the top of the whisker, is the maximum occurring value, and this is the minimum occurring value. So we are comparing two groups, for example. So instead of just comparing the medians, we are also able to compare the maximum occurring value as well as the minimum occurring value as well as the quartile. So we are getting a lot of information from just simple figure. Another important thing in this graph is these dots, which actually denote the outlier. So this dot is actually an outlier. Now dot plot. Dot plot, if we look at this figure, is actually similar to a stem and leaf plot, and it is an alternative way of displaying the distribution of a set of data. Particularly useful for small data sets similar to a stem and leaf plot where a histogram may be uneven, and useful for showing the distributions in two or more groups side by side. And each value is plotted on the y-axis while the x-axis denotes the group. So x-axis is denoting the group or the category, and this is the height. So there are, let's suppose this one is 160, so we can count the dots and we can say how many repetitions or participants were there for 160 in the non-manual group, and we can get that information. Now shapes of distribution. So it is not necessary that it should be a perfect curve or perfect bell diagram. So it may not always be a symmetric distribution. So shape is very important because by looking at the shape of a distribution, we can learn a lot about a set of data in terms of its central values, extreme values, and the bulk of the data is. So for example, symmetrical distribution and non-symmetrical distribution, either in the form of a positive skewed distribution or a negative skewed distribution. And in symmetric distribution, you can see that central values, mean, median, and mode all lie in the same plane, but in the positive or negative skews, we can see that there is a difference in the mean, median, and mode. In negative skew, mean is smaller than median and mode, and in positive skew, mean is greater than median and mode in this diagram here. Now, positively skewed data. What is a positively skewed data? So many variables follow reasonably symmetrical distributions such as adult weight and height, but sometimes they can be skewed and abnormally distributed, and this is known as skewed data. So if you look at this picture here, most of these skewed variables have a positive skew. And what is a positive skew? The tail on the right hand side, so this is the tail on the right hand side, is longer than that of the tail on the left. So this is known as a positive skewed distribution. On the other hand, it can also be a negatively skewed data or negatively skewed distribution in which the tail is longer on the left hand side, and it is comparatively unusual to see negatively skewed data in medical research where the longer tail is on the left, because comparatively positively skewed distribution is more common. And the gestational age is such one variable, which is an example in which negatively skewed distribution or data can occur. Now, displaying categorical data. How can we display categorical data? So graphs can be used to provide visual summaries of categorical data, either in the form of bar charts or pie charts, which are the two most common types. So bar charts, this is a bar chart in which, once again, similar to a histogram, we have the frequency on the y-axis and we have the categories on the x-axis. And in a bar chart, each category is given its own bar along the horizontal x-axis. And the height of each bar is proportional to the frequency of observation, similar to a histogram, which we already discussed in the previous slide. So this is a bar chart and again give you a good information regarding the frequency distribution of the categories. So you can use the bar chart for frequency distribution instead of a table. Moreover, pie chart can also be used for denoting frequency distribution, especially in the terms of percentages. So it shows distribution of individuals in different categories of a variable, where every individual belongs to one and only one category. So here we have three categories, like for example, health status, good health, fairly good health, not good health, and we have the individuals distributed in the pie chart in the three different categories. In a pie chart, each category is given an area or slice of the graph, and area is proportional to the frequency. The greater the frequency, the greater would be the section of the area or the slice. And it is calculated by dividing the whole pie, taking 360 degree as the whole into smaller slices. Pie charts also enable comparison of proportion in different groups. So you can put two pie charts and compare them with each other. As for example, here we are comparing the health status of in Bristol with health status in England, and that's pretty much similar. The only difference is 68 to 69 and 23 to 22 here, which is very small and minute. Moreover, pie charts are only useful when there are 3 or more categories, because if there are less than that, it doesn't make any sense. But it becomes hard to read if there are more than 10 categories. So if there are more than 10 categories, then avoid using a pie chart. And it is not needed when there are only 2 groups, because this information can simply be written descriptively as the proportion of male to females, because males to females has 2 categories and it is a categorical variable. Now, how can we produce charts? Now, as we already talked about different statistical packages, so producing charts, both bar chart and pie chart, can be easily produced using those different software statistical packages. And many packages will produce 3-dimensional graphs as well. But be careful whenever you are making 3-dimensional graphs, because there are some drawbacks associated with them, which is that they are usually not recommended, because using these for simple graphs can distract from the data summary, first of all. Secondly, with pie charts, 3D imaging can produce a misleading graph, as they are in a 3-dimensional shape and the area of the slice is no longer proportional to the number of observation, because it is presented at an angle. With bar charts, it is harder to deduce the frequency because of its 3-dimensional shape. You cannot appreciate that which line is actually the line showing the frequency of that category. So that is not advisable. But you can use 3D graphs, which can be very useful if you have complex mathematical relationships, especially when you are using x, y, and z axis, all of them at once. So it can be useful in that sense. So that was all about this lecture. I hope you learned something new out of it. And keep on watching sqadia.com for more lectures like this. This is Osama signing off. Thank you very much.